Turned out a whole bunch of issues to do with the fact that the figures for the state machines, the tables for the state machines, and the explanation for the state machines didn't necessarily have the same number of transitions in them. They were mostly consistent, but occasionally we'd missed one. And Pavlin did a really careful read-through of this and found, I think, all of them. And they should now all be consistent. Also, the wording and some of them has been changed, so it's very clear that this transition in the figure is the same transition as this in the table, is the same transition as the explanation of it. So hopefully it should read more clearly now. Okay, that was all the real changes. There are a bunch of clarifications. The register tunnel behavior was really rather unclear in the previous spec. So there's a bunch of text gone in to explain what we meant by adding and removing register tunnels in terms of how that mapped into the state in state machines. So hopefully that makes some sense. When I was fixing that, there was a minor bug that cropped up, which was we previously said when the RP for something changed the destination of the register tunnel. And, well, not all things moved to the same new RP, not all groups moved to the same new RP. So just change the wording to make it clear what we really meant by that. Again, if you implemented without thinking about it from the old spec, you would have probably got caught out by it. But, hopefully nobody's implementing without thinking. The assert rules rationale in the previous spec had been basically a dump of the notes we'd taken in some meeting at some point, and it read like it was definitive, and it wasn't meant to be. It was meant to be an explanatory notes. So Hugh has done a complete rewrite of that section to make it much more obvious that this is explanatory and not definitive. There are a bunch of open issues remaining. This one we discussed on the mailing list, and we didn't get resolution, so I'd like to try and get resolution today. This is the algorithm for doing group to RP mapping. This is kind of irrespective of whether you're doing BSR or AutoRP or some other random mechanism for getting the set of group ranges to RP mappings. It's once you have a bunch of group range to RP mappings, how do you choose which one to use? And the rules in both the previous spec and the current spec basically say, first thing is you perform longest match on the group range, you'll get a list of RPs. Of those, take the one to the highest priority. If there's only one remaining, use it. Otherwise, use the hash function. RFC 2362 didn't do longest match. It basically was the same set of rules, but the first number one was missing. If you don't have overlapping prefixes, then it doesn't matter. I mean, they'll behave the same. But if you do have overlapping prefixes, they won't interoperate properly. So we polled the mailing list, and 4 people responded about what their implementations did, and 2 people said they did it the new way, and 2 people said they did it the old way. So what do? I prefer to do it the new way. There's a side issue here, which is if you're using BSR to provide the group range to RP mappings, the semantic fragmentation is a pain. It means that the different group ranges may end up in different packets, and you can't tell necessarily whether you've lost one. So both solutions will eventually converge to the right answer, but it's likely to converge faster if you do the longest prefix match first. This is only a minor side issue. I don't think it's a huge big deal. So what do? The current spec says do longest prefix match first. I would prefer to leave it that way, but I want to hear opinions. Okay, I guess nobody here cares. That's good. We'll leave it that way. Does anybody have a really strong objection to doing that? Okay, no strong objections.
No objection. Whichever way it was going to go, my only request is just related to the bottom point there. In your perhaps changes since RFC 2362 implementation notes, you might say that if you're concerned about interoperability, then you might think it's bad operational practice to have if you want to interoperate, then don't use overlapping prefixes.
Yeah, it's probably worth flagging that that's a dangerous thing to do given the current state of implementations. Okay, so we'll leave the spec the way it is. The other issue also was discussed on the main list. This is an issue that John Zwiebel brought up. The issue is when you have a LAN and you have a lot of people join to the same upstream router and the routing changes. What do? Well, the current version of spec says you join to the new router and you prune from the old. Seems simple enough, except for the downstream routers usually won't learn the new route at the same time as each other, especially if you're using MBGP, which will tend to serialize how they learn about it. So there's a possibility here that what happens is, say, router 3 learns of the change first, and it sends its join and it sends its prune, and let's say router 6 goes, I want to keep receiving from the old one, so it sends a join to override that. And then the next router learns, and you end up basically with each of them, one after another, sending a prune and somebody else overriding it until everybody eventually switches. It turns out that actually, I'm not sure this is such a big deal. It depends very much on how long the prune override interval is. If the prune override interval is longer than the amount of time that it takes people to learn the new route, then one person's override will basically serve for everyone and you won't get a storm. I don't think this is a really big deal either way. If you don't send a prune, you can get traffic flowing until an assert causes the traffic to stop. So it's not a big deal not sending the prune either. But we really need to decide what the spec should actually say.
This is related to the problem we talked about in MBOND, where you have an exchange point. Problem in an exchange point is you may never get convergence about all the participants on the shared media.
Well, actually, the assert will force convergence. And
It may be,
if not,
but it
then you
won't.
have to do VPNs or something like that over the exchange point.
Assert may fix it, but it means that the people selecting the routes don't necessarily get the routes they want.
That's
in
true,
effect.
and that's the nature of PIM on a LAN. And exchange points basically, if they want to do something other than the default behavior, will have to do some other mechanism to enforce that. There's not much you can really do.
Concur.
So there's sort of two sensible possibilities here. The first sensible possibility is to say the normal case is to send the prune, but as an optimization you might choose not to on the LAN. That's basically what the current spec says, except for it doesn't say anything about the optimization. The second is to say that the normal case is not to send a prune, but as an optimization you might consider sending one on an interface where you've only got one PIM neighbor. I'm pretty much agnostic about this.
I think if you do explicit tracking, then you don't have a problem here at all.
That's
Right.
true, but this is really addressing the case where you don't do explicit tracking.
Yeah.
Now, if everybody did explicit tracking, I would personally be very happy, but I
Yeah.
don't think everybody does. Nobody has any opinions.
So I can understand number 2. I'm trying to understand point 1 and what you lose by doing this. Does that mean that you'd be sucking down traffic to the upstream neighbor even though you may not need to, or what? What is it that
In
you
the
actually
case of
lose?
point 1, where you do send the prune. In case
No,
of
if you choose not to send the prune in point 1, what do you lose? Do you lose the ability to prune upstream of your previous old neighbor?
in point 1 is basically if you choose not to send the prune, then you risk the prune storm.
You're not loud enough.
In point 1, if you choose not to send the prune, then you risk getting the storm.
You risk getting what?
If you do send the prune, then you risk getting the storm.
Right. If you do not send, right now it says
If
to send
you-
the prune. If you stop doing that, what do you lose?
If you don't send the prune, then
Sorry,
traffic
you're
from
right.
upstream may have to time out, right?
Yes. Well, if it's on a LAN, there'll be an assert.
Not if your RPF interface is different and nobody's forwarding. I mean, there can be tie situations
Yeah.
where nobody else is the forwarder for this LAN. The LAN stops being transit,
That's true.
and then it would have to time out.
Yeah.